This is the graph for the transform mesh modifier. There are 5 components to the graph. The first part is the computation of the translation vector. The translation vector represents the offset in space along the x, y, and z axes. The second component of the graph is the computation of the quaternion that represents the rotation. The user exposed 3 parameters that are each representing degrees rotation around the x, y, and z axes. These are also known as Euler angles. The Euler angles are converted from degrees to radians, and then a quaternion is computed from the result. Next, the scaling values, which are represented to the user as percents, are computed from the 3 parameters. The rest of the graph needs the values to be converted from the range 0 to 100 to the range 0 to 1. This is done by the compound vector 3% to ratio. Given these 3 separate components, a matrix is constructed. The matrix is then passed to the mesh transform compound, which applies the matrix to the position of each vertex in the mesh to compute a new mesh. This compound takes into account a soft selection channel if present and does a linear interpolation under the hood between the old vertex positions and the new ones. The final result is output to the modifier and passed up the modifier stack.